Guys, in this video we will discuss about the power series. So first of all, we have to define that what is power series. That if a series is of the form a0 plus a1 x minus a plus a2 x minus a whole square plus dot dot plus an x minus a whole to the power n and so on, and in compact form we can write that n is equal to 0 to infinity an into x minus a whole to the power n. This is a power series in x minus a, where a0, a1, dot dot an are real constants and this a belongs to R. So since a belongs to R, then it may be that sometime a is equal to 0, and if a is equal to 0, then we can rewrite this power series is of the form a0 plus a1x plus a2x square and so on, and we can write in compact form, that is n is equal to infinity an to the power n into x to the power n. This is known as the power series in x. So now we are going to discuss about that how to find the interval of convergence of a power series and how to find the radius of a convergence in power series. So basically, first we have to emphasize on how to find the radius of convergence of a power series. So basically, for finding the radius of convergence of a power series, we use the D'Alembert ratio test or Cauchy root test. And the basic rule to find by using the D'Alembert's rule or the Cauchy root test, that first if we follow that using the D'Alembert ratio test, then we first find that limit n tends to infinity a n plus 1 by n, which will gives a finite quantity lambda. Then the radius of convergence is of the form 1 by lambda, and the radius of convergence is denoted by small r, and the radius of convergence is 1 by lambda. And when we use the Cauchy root test, then we have to find that limit n tends to infinity, when we use the Cauchy root test, that is limit n tends to infinity, that is an whole to the power 1 by n, which is equal to lambda, and here this lambda not equal to 1, but lambda is a finite quantity. So both lambda, then we can get it by either D'Alembert ratio test. When we use the D'Alembert ratio test, then we use this formula, and when we use the Cauchy root test, then we use this formula, that is limit n tends to infinity a n whole to the power 1 by n is equal to lambda, and where lambda is not equal to 1. And then, so this is the radius of convergence, that 1 by lambda is equal to r, and the radius of convergence is denoted by small r. So now the question is that how can we find the interval of convergence? So we can say that the series an into x to the power n converges absolutely for all real values of x if the interval of convergence is minus r less than x less than r, and diverges for mod x greater than r. So the series an x to the power n converges absolutely for all real values of x if the interval of convergence is minus r less than x less than r. So we can write the interval of convergence for the series an x to the power n is minus r comma r, and the power series is of the form an x minus x0 whole to the power n. This power series will be convergent if x minus x0 mod of x minus x0 less than r, and divergent if mod of x minus x0 greater than r, where x0 is an arbitrary point. That is, we can say here that in this form that x0 is equal to a. And the interval of convergence for the series an x minus x0 whole to the power n is x mod of x minus x0 less than r. So from here we can write that mod of x minus x0 less than r means we can write x0 minus r, that is minus r less than x minus x0 less than r, or we can write it x0 minus r less than x less than x0 plus r. So the radius of interval of convergence for the series summation an x minus x0 whole to the power n is x0 minus r, x0 minus r, open interval, x0 minus r, comma x0 plus r. So now I just show you two problems that while we use the D'Alembert ratio test and we use also the Cauchy root test, and also they belong to, one is the power series against the point, about the point 0 and about the point x is equal to point x0 which is not equal to 0. So now let us see this question that find the radius of convergence of the following series, that is x by 2 plus 1 by 3 into 2 into 5 x square plus 1 into 3 into 5 by 2 into 5 into 8 into x cube and so on. So see here we can denote the series by n is equal to 1 to infinity n x to the power n. So from here we can write that n is equal to 1 into 3 into 5 dot 2n minus 1 divided by 2 into 5 into 8 into dot 3n minus 1. This is the general term of the series an. So now what will be the an plus 1? That is an plus 1 is 1 into 3 into 5 dot 2n minus 1 into 2n plus 1 and 2 into 5 into 8 into dot 3n minus 1 into 3n plus 2. So now we have to find the ratio of an plus 1 and an. So limit n tends to infinity, an plus 1 by an is equal to, we can write that limit n tends to infinity, put the value of an plus 1, that is 1 into 3 into 5 into 3n minus 1 into 2n plus 1, 2 into 5 into 8 into 3n minus 1 into 3n plus 2. And this will be now 2 into 5 into 8 dot 3n minus 1 and 1 into 3 into 5 into 2n minus 1. So if we now simplify, see here that only the 2n plus 1, the 2n plus 1 and 3n plus 2 is the term which will be not cancelled. So we can write here limit n tends to infinity 2n plus 1 divided by 3n plus 2 is equal to 2 by 3. So now this is the value of lambda, and we know that the radius of convergence r is equal to, the radius of convergence r is equal to 1 by lambda. So we can say that the radius of convergence is 3 by 2. And we know that if we add here the convergence, the interval of convergence or the interval of convergence, then that is minus r to r. So the radius of convergence is also minus 3 by 2 comma 3 by 2. I hope you understand. And now for next problem we will, for this question, that find the radius of convergence and the exact interval of convergence of each of the following series. That is, we consider here x minus 1 whole to the power n by 2 to the power n. So this is a very simple problem. That is, see here n is 1 by 2 to the power n and n plus 1 is 1 by 2 to the power n plus 1. So here we can use that limit n tends to infinity n plus 1 by n, that limit n tends to infinity 1 by 2 to the power n plus 1 into 2 to the power n, that is half. So this is our lambda. So the radius of convergence will be the reciprocal of this value. So the radius of convergence is 2, and the power series here, that is given that x minus 1 whole to the power n. So see here the series will be convergent if mod of x minus x0 less than n, and here r is equal to 2, and the interval of convergence will be x0 minus r comma x0 plus r, and here x0 is 1. So we can say that interval of convergence is 1 minus 2 comma 1 plus 2 or minus 1 comma 3. So I hope you understand that how can we find the radius of convergence and interval of convergence by using D'Alembert ratio test. So thank you.